So yeah, today we're going to be talking about CI/CD, and I'd like to ask everyone if they actually know what CI/CD is. Can you raise your hands? Well, more than I expected, so we're going to be good. Cool, so let's get ready to it. My name is Ignacio, as Bear just said. I go by Congonator online, so if you play in CTFs, you've probably seen my name as Congonator, not Ignacio. I'm a cloud security engineer working at Holborn, and I do a lot of CTF development with John Hammond, who's here today. We call ourselves Just Hacking, and we've done CTF like NahamCon, HackTricks, some GrimCons, and a couple of B-sides. But that's enough about me. Let's get to what we're all here for. So this is today's agenda. We're going to be covering first a little basics for those that didn't raise their hands about what CI/CD is. We're going to look at how the CI/CD flows normally look like, why people are using CI/CDs in almost every company, at least in the companies I've been looking into, mostly startups. Everyone's using CI/CD, so let's see why they're doing that. Then we're going to look into security of CI/CD. This is a security company after all, a security congress after all, so let's actually talk about the security and implications of CI/CD systems. And then we're just going to be, I don't want this to be a death by PowerPoint presentation, so we're just gonna briefly talk about all the theory first, and then we're just gonna jump into some examples of scenarios that I found in real world engagements, during engagements with clients, and yeah, then some conclusions and mitigations for the attacks we're going to demonstrate live here today. So what is CI/CD? CI/CD has two parts. The CI, it means continuous integration, and this is the automated integration of code, which allows teams of developers to work in parallel, so they can provide more value to the company faster by iterating at the same time, building features. In order to accomplish this, CI does a lot of automatic tests and a lot of builds whenever new code gets merged into a central repository. That way, they can automatically test that one developer's changes are not breaking another developer's changes. Secondly, CD, there's different definitions about this depending who you ask. The two main ones are continuous deployment and continuous delivery. For me, they're different things, although sometimes they do get used interchangeably. For me, continuous delivery is when you're building some kind of package or a container image, some kind of artifact, a module, a package, a binary, and then once that's built, that would be part of the CI. Then you have to deliver that to some kind of repository, some kind of artifact repository where other clients can go back and pull it. On the other hand, CD can also mean continuous deployment, and this is all about deploying changes that have happened directly into production from wherever the changes that they've made in the repo. So normally it goes like this. First, the developer does a commit, they release their new feature, they open a pull request normally. So developers will make this pull request, and that will trigger a CI/CD pipeline. A pipeline is nothing else than just a set of steps that get executed in an automated way with a purpose. Normally, during this pipeline, you will see things like compilation of binaries in the builds part. And those binaries, it could be binaries, it could also be container images, some kind of package like an npm package, or maybe a Python package, something like that. There's also a section of these steps in the pipeline that will be about running tests. This is to make sure that the changes that one of the developers introduced are not going to break the existing functionality of the application. These tests could be unit tests, integration tests, or even end-to-end tests in more advanced scenarios. And this is just to make sure that no new issues are getting introduced. Then there's the delivery phase, which is just if you've built something, you need to send it somewhere, because if it stays in the runner where the pipeline has executed, then it's useless. No one's going to be able to use it. And therefore, you need to upload it to some kind of repository. And finally, there's the deploy stage, normally, and that's when the pipeline will actually deploy changes to a live environment where users can actually use it and take advantage of the new features. So why are companies using CI/CD? This is mostly, in my experience, most startups are going with CI/CD, and this is due to the fast development cycle. I've been in startups that have been making over 60 deployments a day to production, which is insane to think 5 years ago. And this is all due to CI/CD pipelines. They can go from a Jira ticket with an issue to a fix within hours, thanks to having everything automated, all the testing, all the deployment, everything's automated. So along with the testing, you can also include security scans, like software composition analysis or static analysis, and that could shift left security in order to make the developers aware of any security issues way before they reach production. Deployments are made automatically. That means no one's going to fat finger anything. Everything's going to work hopefully well, and there's not going to be any issues deploying. It's going to be fast, practically immediate, and it also means that it's easy to roll back due to the fact that you just have to revert the state in your repositories and click a button, and that will deploy the previous version or whatever safe version you have, and therefore you get rid of any issues that have been discovered in production. So about security of CI. CI/CD is super cool. Everyone's using it. It's super useful, makes life easy, but it also comes with a big disadvantage, and that's security. It's very tough to secure it, and it can go wrong very fast. Since we're giving it credentials to do things like deploying directly to production, it's very probable that you will end up in a situation where you have to give production credentials to the CI/CD pipeline. Some examples that come from the OWASP Top 10 CI/CD security risk, which has recently been kind of released. It's kind of like in beta. It's still under review. So these are the ones I find relevant for this talk. There's a bit more about it. But the first one is lack of pipeline flow control. This means that there's no control over who can execute what parts of the pipeline. So if an attacker was able to execute a part of the pipeline they shouldn't, they could be able to deploy things to production or leak some kind of credential that they shouldn't be able to do. Then we have poison pipeline execution, which is a fancy name someone put to changing a configuration file that has the steps and then executing the pipeline. The aim of PPE, poison pipeline execution, is to normally to steal secrets, some kind of secret that is used during the pipeline execution. And one of the main issues is also that this is normally done in startups, they just want to get this working. They need it to be fast because of integration cycles, a lot of pressure from above. They need this to be set up and working fast, and therefore they just give a lot of permissions to the roles that are used in the pipelines, not following least privilege. That could mean you find pipelines that are running as AWS admin, or things pretty scary like that. Finally, supply chain attacks are something that typically happen in CI/CD pipelines. An example of it is CodeCov, and I won't be covering much about supply chains in this talk, but if you're interested in that, stay tuned because John is going to be talking about this tonight. And that's it for this slide. So we're mostly done with the PowerPoint stuff. We're just gonna jump into some real life scenarios. I'm gonna walk through some diagrams to kind of explain what's going on, and then we'll do some live demos. Cool, yeah, so in most of these scenarios, developer access equals AWS admin. These are all based on real life engagements and have been slightly simplified to make them more appealing to the presentation today. So the first one is about poison pipeline execution. This is when an attacker can just modify the configuration files of a pipeline, and therefore they can change what's running in each of the steps. This could give them access to secrets and infrastructure credentials, as we mentioned. There's several types of PPE. The first one is direct, and the second one is indirect. In the first one, the attacker has permissions or has the ability to directly modify the steps in the pipeline, like in the configuration files. Normally, it's like a YAML file. And indirect ones are where the configuration files in the steps are calling other scripts, and the attacker has the ability to change those scripts. Like, for example, if there was a make file, and the pipeline is calling make build, you could change the make file to when the build command is run, it could do whatever the attacker wants, like exfiltrate some credentials. And another thing to keep in mind is that these command injections, these pipelines could be vulnerable to command injection. This is any user-controlled input, which could be a branch name, a commit message, anything like that, could be used to exploit a vulnerability in the pipeline if those variables are used incorrectly with no validation and no filtering. So here is the first diagram that we're going to see tonight. And in this scenario, there's a GitHub repository, which doesn't have branch protection. That means anyone with write access can push directly to main. And the attacker has somehow gained access to a developer's account in GitHub. So they're going to make changes to that GitHub repository, and that will trigger a GitHub Actions because the repository has been configured this way. This GitHub Actions, which is, I don't know if everyone's familiar with GitHub Actions. It's a CI/CD system that GitHub offers. So GitHub Actions has been configured to run this pipeline with an AWS role right down here. That role is going to have some pretty big permissions, and it's used to create other AWS resources. It could be uploading packages, images, or just creating anything with Terraform. So let's go to it. The scenario that I've created is an S3 bucket, which is configured to be publicly available and set up as a website. So what we're seeing here is just a file inside an S3 bucket, and that file corresponds to this other file. Then we have the pipeline. This is all in a repo called PPE. We have the pipeline, which is running the following command: AWS S3 copy, and it's copying the file I just showed in the .html into the bucket. If you were to try to copy something to a bucket that's not yours, you would get actually permission denied, and that's why we are specifying here that we're using an AWS role, and that role is this one. I'm just gonna copy it, and we're gonna actually look in AWS to see what permissions that user has. Hopefully the internet doesn't break. Cool, so let's go to roles and search for my role. And under permissions, we can see this role has, maybe you can't see because this is tiny. This role has all of these permissions. This is incredibly overprivileged for what this is actually doing. It should only have like S3 put object into the resource that's actually being modified, only that specific bucket. In this case, it has something like IAM, every action from IAM that could allow to privilege escalate to AWS admin instantly. We're not gonna cover that part because that's not really too interesting. So let's go ahead and modify our pipeline step. And this would be what the attacker would do. So we can just append to this command, and we're gonna run env. Then we're gonna grep for AWS. And GitHub Actions has a protection against printing sensitive objects that are considered secrets in the logs from the action, and it will mask them. So instead of GitHub Actions masking them, we're going to base64 encode them, and that will avoid GitHub Actions from being able to mask them. So just saving that, and now in here I'm gonna commit git add, git commit, and we're just gonna push. This repository doesn't have branch protection, so we can just push to main. And with that, that's already done. Cool, so let's go to the repository. And now we should see there's a GitHub action here running. Let's check the details. And once it starts, here, okay, it started, it's running, and that's our base 64. Let me open it again, here. Cool. We can see a base 64 string. We can just copy it and decode it. I don't like that copy, that something went wrong. Let's just try. Okay, yeah, it did work. So now if we export these credentials, yeah, I'm leaking AWS credentials over a 10-meter screen. I'm kind of trusting you guys. These are temporary credentials, so it's not that bad. Hopefully no one has time to actually take a screenshot and do anything dodgy. Cool, and now we can just run AWS STS get caller identity, and this will tell us who we are currently authenticating as to AWS, and we should now see the role that we saw before was being used by that pipeline. That means we have managed to get the role from the pipeline and exfiltrated it to the attacker's machine, and now we could escalate our privilege to AWS admin. Cool, on to the next one. Oh, first we're gonna talk about some mitigations. So it's a good idea for all public and fork repositories to disable pipelines. This is so people cannot just create a fork of your repository and then submit a PR and execution will start automatically. It's disabled by default in GitHub, so you don't have to do anything in GitHub, but you should check that it's actually disabled. Do not trust pipelines. So if the code has not been reviewed, run those pipelines in an isolated environment with no access to production. Maybe use some kind of staging environment. Normally, companies do not like code to be reviewed to be able to test things, because that means the developer lifecycle gets slower because they have to have reviews between every change. So normally people tend to have some kind of staging environment where they can run these pipelines without any implications of compromising production environments. Also, ensure branch protection is in place. We're going to talk a bit more about branch protection in a couple slides, so I won't cover that too much. We need to make sure that only the required people have access to the repositories. That would be like any kind of access, not only admin access, also write access and read access. Also, always try to use least privilege roles. We saw that the role that was being used in the demo was completely overprivileged and there was no need for it. So make sure least privilege is being followed. And finally, some CI systems support this and others don't. If you can, try to make sure that the configuration is always pulled from the base branch, because that branch hasn't been tampered with if there's branch protection. That would mean that if an attacker was to change the configuration in a pull request, then the base branch, which hasn't been modified, would be the configuration that gets used during the CI/CD pipeline. Cool. We're now going to move on to another subject slightly. This is Terraform. We're still going to be performing what technically is a PPE. So it's essentially the same attack as before, but this one is indirect. We're going to be using Terraform plan in order to achieve RCE, and therefore exfiltrate whatever credentials are being used by Terraform. So there's several ways to do this in Terraform. The ones that I've used in the past are external providers. The external provider is a provider that allows you to execute external programs that are not Terraform during the Terraform plan. This means, for example, if you needed to execute some kind of Python script to generate some data while you're running Terraform, I'm assuming people know what Terraform is. Maybe people don't know. So Terraform is a system that allows you to create infrastructure with configuration. So it's an infrastructure as code system. And you can just define, for example, I want an S3 bucket and maybe a Kubernetes cluster, maybe some databases. For example, in AWS, you configure them through code, and Terraform will be in charge of actually making them. Then we've got the external I just explained, and then we have custom providers. So it's possible to create your own providers in Terraform. There's official ones, like the AWS one, or Kubernetes providers, but you can also create your own one. A provider is nothing else than just an API client. So the provider will talk to an API which creates the resources, and therefore you can create your own, and it's just Golang code, so it could be malicious. If you call your own provider from the Terraform plan, you essentially have RCE because it's going to run your own Go code. I linked here a blog post from an ex-colleague which covers this in detail, and it's really interesting. So this is not the attack. This is the actual expected flow of this kind of. It's probably tiny. No, you can see it. Okay. So yeah, this is the flow that normally people use when they're doing Terraform. Developer 1 submits a PR, which includes the workflow for the pipeline, so the steps. That file is protected. They cannot change it, so they can't do direct Poison pipeline executions. They can only do indirect. And then they have the Terraform files, which define the resources. Then they open a PR from the branch that they created. A second developer will come in. That push to that opening of the PR will create a GitHub action, which again uses a role from AWS. The action will perform a Terraform plan, and the output of that plan will be injected into the PR as a comment. Then it's when a second developer can come in, check the code, check the output of the plan, make sure everything's looking good, there's no dodgy stuff, and they can click approve on the PR. And then that would trigger, when they merge it to main, that would trigger another GitHub action that actually creates the resources in AWS. So how could an attacker take advantage of this? In order to create resources, they would have to achieve to reach the plan, the apply state, and that won't be possible without someone else looking at their code. So they have to achieve RCE during plan and exfiltrate some credentials. So they're going to include an external provider in the Terraform in the Terraform configuration. Then they're going to open a PR, and during the execution of that pipeline, the PR, the Terraform is going to execute their own code with the external provider, and it's going to exfiltrate some credentials back to their machine, which they can then use to authenticate to AWS. And enough talking, let's actually do something. Cool, I need to move in here. Let's close this. Cool, Terraform RC. Okay, so in this example, the Terraform that's being run, this is also in a repo in that same GitHub, is just creating an S3 bucket, pretty boring. So what we're going to do is use this small bit of code, which is just creating a new data resource from the provider external, and it's going to run the exfil.sh script, which we still have to create. So that's the next thing we will do. Just paste in this, saving, and now in here, I need to create a new folder, call it exfil.sh, and we can copy this simple script, which will just print the env and send it to an attacker control server. This could be a reverse shell, but I'm lazy. Just creating a reverse shell to then run env doesn't make any sense. So just running env directly. I was also meant to show you that this repository does have branch protection, even though we're gonna have to use a bit of our imagination because of some limitations with free organizations in GitHub. If we go into branches here, we can see this big banner telling us that there is some kind of limitation to free organizations and branch protections are not enforced. Regardless, we're gonna act as if they were. I'm just gonna show you the configuration of the branch protection. We're requiring a review before a merge, and we need at least one review. If there were to be any changes after that review, there would need to be another review. And finally, it's not possible to bypass this just because you are an administrator or you have the branch protection bypass permission. Cool, so now that we've seen that, this is all saved. I need to change directory. Cool, just going to switch to another branch and commit this. And push to the branch. Okay, now we can go ahead and here it already detected that we have some pushes to another branch, so we can just create the pull request. Doji is a good enough name, so create the pull request. And now we should see a build start right here. I forgot to set my listener, run. No, my SSH session died. No problem. Cool. So we're listening on port 7000, and apparently we got some kind of request, probably from someone in the audience. Yep, one sec. Cool, so we're listening, and let's go back in here and re-trigger that pipeline. We probably got a connection refused yet. So we need to rerun this job, rerun all jobs. Okay, the job is starting, and now we should see a Terraform init. This is the first command Terraform runs just to initialize the repository. And then it will run a Terraform plan, which will actually connect to our server and exfiltrate those credentials because of the external provider. Okay, it fails because my server is not responding with anything, but here we have the entire environment, and somewhere in here are the AWS credentials. Here we have an AWS session token, and there should also be an AWS access key and a secret key. I'm not gonna look for them, it's not interesting enough. Again, we could export this, thanks. These credentials could now be exported and used from the attacker's machine, which would mean that he's an AWS admin. Cool. Mitigations against this. Do not run untrusted Terraform plans. That's very difficult. If you tell that to your DevOps team, they will kill you. So other alternatives, instead of doing that, is run your Terraform plans in non-production environments. Probably DevOps is still going to look to you weird just because they will want to know the output of Terraform plan in production environments before merging. So the next better option, I would prefer that one, but DevOps is not going to let you. So another option is to run all the plans with read-only roles in AWS. This would mean that even if an attacker was able to compromise these credentials, they wouldn't be able to be as destructive. They would be able to read some values and some things in the cloud, but probably not cause the amount of impact that you could cause with AWS admin. Then this one is one that I haven't seen, anyone do. I have not tested, so I don't know if it works, but theoretically it should work, and I think it's a good approach. Maybe tooling is lacking a bit. It would be a bit complex to set up, but there's this tool called tfsec, and this tool can be used to make checks over your Terraform configurations, which allow you to determine what kind of resources you can create. So for example, you could have a check that says there's no, you can't do public S3 buckets because that's insecure. So this tool also accepts Rego checks. Rego is a policy language which allows you to create any policy to check for things. And you could actually use this Rego language to check for providers. So if you detect that there's any provider that is not in your allow list, you could say, okay, this stop the execution of the pipeline. This is not safe. If anyone wants to actually test this, they will need to use the no ignores flag, because in tfsec, you can just add a comment on top of the line that's affected, saying, okay, please ignore this check. This is safe. And we don't want the attacker to say that their attack is safe. So you would need that flag. The final option I could think of is the plugin dir Terraform flag, which allows you to specify a directory that can be used to keep all the pre-installed providers. So you would download all the providers that your Terraform configuration normally uses, store them in a file, and that way you avoid Terraform from reaching out to the Terraform registry or other registries and trying to seek any dodgy providers. Cool, we'll move into Kubernetes. I love Kubernetes. I don't know about the rest of the world, but Kubernetes is magic. So there's two ways to do CI/CD. There's two ways to create things in a declarative way in Kubernetes. The main one that you'll see in all the tutorials is directly creating manifests. These are either YAML or JSON files, and you just define whatever resources you want to create in your cluster and apply them. Then you have templated Kubernetes manifests. The first that come to mind is Helm charts, just because of how popular they are, but there's other alternatives. In this talk, we're gonna talk about Helm charts. And the pros of this are that it makes your manifest really reusable. You could have different environments all using the same manifests because you have the ability to use logic operators, comparators, loops, variables, and therefore, for example, if you wanted to, in your staging environment, only have 2 replicas of a service, and in your production environment, you want to have like 10 because of the traffic that it receives, you could use just the same Terraform, just the same Helm chart, but with a different value for a variable. Also, it's really easy to version them. You can just set the version in the chart manifest. There's a specific chart.yaml file where you have a version field. You can change it, update it, and then rolling back is just as easy as changing the version back and reapplying the Helm chart. So GitOps paradigm. This is a way of doing CD, which uses a Git repository as a source of truth. That GitHub repository will hold the desired state of a system, in this case, for example, Kubernetes. So different teams could have their own GitOps repositories, and they would store the desired state of their applications. So if they want a deployment, they could just create a Helm chart with a deployment in it and stick it in their GitOps repository. And then there's some automated way that will actually look into that GitHub repository and apply that state to the system in production. So essentially, a developer only has to push changes to Git, and everything happens magically. So Argo CD is a tool that can be used for this. There's other tools like Flux CD, but Argo CD is the one I've used the most, so that's what we're using now. And it uses Git as a source of truth. It also is compatible with Helm charts, along with customize and other kinds of templating things for Kubernetes manifests. And it will check periodically to make sure that your cluster configuration is coherent with the state that you've specified in your Git repository. So security about GitOps repositories. If someone can push to the main branch or whatever branch is getting synced into your production environment, if someone can push to that branch, they can control the state. So it's essential that those branches are protected and people cannot push to them directly. Everyone should be submitting a PR, and there should be some kind of review process in place to make sure that there's no dodgy changes that would break your production environment. So you should enable branch protection, but there has been ways to bypass these protections in the past. One of them, the blog post is linked right here. It essentially is that you can use GitHub Actions to actually apply a review to one of your PRs, essentially bypassing it. So you need a PR and you tell GitHub Actions, okay, approve my PR, and GitHub Actions can do that. GitHub has come with kind of a fix for this. They now have an organization-wide setting that allows you to, by default, it's disabled in new organizations, but if you go back in time to old organizations, this protection is disabled. It allows you to tell that GitHub Actions cannot approve or create PRs. So if this checkbox is enabled, you're vulnerable, and you're able to bypass the pull request. We'll see this in the example. Then there's also PR hijacking, which is when you find someone else's PR, you modify their code, and then you review it yourself. Since you didn't open the PR, you have the permissions to review it. Okay, so this is the flow that normally happens, no attack here. Developer 1 opens a PR, developer 2 looks through the code, through the charts in that GitHub repository, says, okay, everything looks good. The developers can then merge that PR into main. And normally, you can configure this two ways. The cool way is to have a GitHub webhook that will notify Argo CD and tell them, okay, there's been changes, you should come check. So Argo CD will go there and collect the charts and tell Kubernetes, okay, I have these new charts, they have changed in this way, can you please apply them? And the cluster will go ahead and create any resources that are needed, modify anything that's needed. Then Argo CD will keep constantly checking that repository. So if you don't configure the GitHub webhook, you're still good. Eventually, after a couple minutes, Argo CD will go back and look at your repository and sync it. So how can an attacker take advantage of this? If an attacker was able to bypass branch protection and they're able to push to the main branch, that means they control the desired state, and therefore Argo CD will say, okay, the state has changed, I'm just going to create something that someone told me in the cluster. In this case, we're going to be used what's called a bad pod, and this is a pod that has a container which is privileged, and since it's privileged, they will be able to escape the container. In this case, we're just going to mount the host file system, and that will give us access to the node of the cluster. And from there, we can try to exfiltrate some credentials for other service accounts, and therefore become Kubernetes admins. So yeah, basically, the bad pod is going to make a connection back to the attacker, and that will create, then we will be able to gain access to a token that is a Kubernetes admin. Okay, let me close some stuff. So let me first show you what my Argo CD looks like. This is the UI, it's pretty nice. We have an application of applications. This application is just specifying that we have Nginx application. If I was to open this, I believe, in the manifest, we should see that there's a GitHub repository here specified. This is the repository where Argo CD will go look for the manifest for this application. So let me just show you that here. Okay, this repository also has branch protection, and here we have the chart, which contains the Helm chart, and there's these files, which are the manifests that get installed when you install this application. So what we're gonna do is scroll down. Okay, This first part I'm copying now is the configuration for a pipeline, so a GitHub action, and it will just approve the PR for us. So it has the permissions pull request right, which are needed to approve a PR, and then it just calls the GitHub API to approve this PR. So we need to create the folders for this to be a valid GitHub workflow. And then we create the file. Cool, that's done. And then we can create a bad pod. In this case, I copied this from Bishop Fox's repository. They have a bunch of examples. And as we can see right here, it's mounting the nodes file system into the host directory. And it's just creating a reverse shell back to our attacker control server. Now I'm going to remember to set up a listener. First, I'm going to actually paste that thing before I lose it. So I'm just going to paste it in one of the YAML files that I know gets executed when this gets synced. So with 3 dashes, we can append another manifest. And now when this deployment.yaml gets synced, we will also have our bad pod. So back to my notes, set up the listener. My SSH didn't die. Okay, we're listening. And now we need to submit that PR. Switch to the Doji branch. Add all the files. Commit and push. Now we should see this in a PR. Open it by hand. Okay, here. This should tell us that there's new code, and if we want to open a PR, we do want to open a PR. Create the pull request. And now, this is really funny. I really like this. We should see GitHub action start, and all of a sudden, our PR will be approved. Yeah, GitHub actions just approved our PR, so we can go ahead and merge our pull request. Now, when this is merged, we have essentially changed the desired state. We could check, I don't have time to check. So if we had the cool configuration and there was a GitHub webhook, that would have happened automatically, but we don't, so we have to go back to Argo CD and click sync. It would periodically check, and eventually we would have this happen automatically. So let me actually go into the Nginx application, and we should see a new pod getting created. Let me think. There should be a pod that appears right around here when this syncs. Okay, that's our pod, and hopefully our listener is going to catch a reverse shell. No, our listener died. I should be able to sync it again. Maybe not. My shells are dying. Anyway, I do have a video, but I don't think it's interesting enough to show it. Trust me, you can get a reverse shell. Oh no, I actually do have to share the video. Yeah. Let's do the video. Cool. Let me skip. Okay, that's the handler. I'm syncing. Okay, there we have a reverse shell. We can see the host name is the node, not a container. And now we need to escalate our privilege to admin. And to do that, we're going to, first of all, change our root of our file system to host. That way, it's easier for us to interact with this. And then we're going to install wget because we need some tools. This cluster is using containerd instead of Docker. And that means that we cannot use the Docker CLI. We need something else to interact with containerd. So we need to pull something called nerdctl. And nerdctl is just a Docker-compatible CLI for containerd. So here we're done downloading it. OK, it's there. So we can execute it. Let me make this faster. OK. I went too far. Unzipping it. Now what we're going to do is just use nerdctl to talk directly to the node's containerd socket and run a PS. Let me show you that in more detail. So we're running nerdctl, connecting to the Docker socket. In this case, it's containerd socket. And then we're running PS. This will show us all of the containers that are running in this machine. And we're looking for a specific one called Argo application controller. So we're going to grab for it. And we're going to find the container ID. And now we're going to exec into that container using the exec command from nerdctl. And now we're going to just, we now have a shell inside a container that is Kubernetes admin. We're just going to print the token from that service account. And let me skip through that. So that's our token. And now we can configure the attacker's kubectl to use this token. And we can see that it's indeed AWS admin. And as we can see, yeah, we could see before it finished. OK, yeah, trust me, it's AWS, it's Kubernetes admin. Cool. Now the last one, really fast. I think I'm really out of time. I see people freaking out right here. So let's go straight to it. Mitigations for this are pretty much the same, branch protection, all of that. One that's cool is Argo CD projects. This allows us to create roles and policies of what kind of thing Argo CD can create. And also, there's policy agents in Kubernetes that you can use. They're technically called admission controllers, I believe. So some of them are Kyverno or Gatekeeper, which uses OPA, and they allow you to create some policies on what can be created and what cannot be created in your Kubernetes cluster. So you could prevent the creation of admin roles or the creation of bad pods in your cluster, therefore avoiding mitigating this attack a little bit. So we're going to talk about Crossplane. Crossplane is a super cool tool that allows you to manage your infrastructure from Kubernetes. And essentially, you can define in your Kubernetes manifests resources for AWS, like, for example, a database or an SQSQ, something like that. Combined with Argo CD, it means you can keep your project and your infrastructure in the same place and do everything in a GitOps pattern. And they also have a really cool logo. So the flow is the same until the part at 6, where the Argo CD will read the manifest, and some of those manifests will contain Crossplane custom resource definitions. And that will allow a container within the Crossplane namespace, which is called AWS provider, to create resources in AWS using, in this case, an admin role. By default, an admin role. So yeah, the attack is basically the same as before. We're going to modify the manifests, and we're going to get control of those credentials that are used to create AWS resources. But since we already have done the first part, I'm not going to repeat it. We're just going to go from our cluster admin shell, which I don't have, so I'll put the video, I guess. And we're going to steal those credentials from the container. This has changed since when I first used this vulnerability. Well, It's not really a vulnerability, it's more of a feature. So this has changed, and now kind of a mitigation is that the Crossplane pod that runs the AWS provider is now distroless. So there's no shell, there's no cat, there's no ls. There's essentially no way for us from being a Kubernetes admin in the node to exfiltrate that token unless we would go through the pain of actually looking for the files of the container within the node, which is a bit of pain. But there's an easier solution. We could create our own node, our own pod, and attach the same service account that this pod is using, and just read from our own pod that has like bash and all the fancy things. So let me put the video for that. I believe this one is short. Okay, yeah. So here I'm showing what a role looks in a Kubernetes manifest with Crossplane. I'm gonna skip through this since it's not very interesting. I don't want to look at the IAM role. Okay, so now, did I skip too far? No, okay, yeah, I'm configuring the token that we extracted before in the previous attack for my kubectl, checking that I'm indeed an admin. And now we just need to create our, we need to first check the service account that's getting used by the provider role, the AWS provider pod, which is called AWS provider and then a number. So we're gonna look for the manifest of that service account, and here we can see that it's using a AWS IAM role that's called CI/CD gone wrong, AWS provider. Therefore, if we mount this service account in a pod, here the video is showing you that that's an admin in AWS. You can trust me. And here we're going to create another, in this case it's a bad pod. It wouldn't have to be, but I was just copy pasting. In this case, it's not a reverse shell. In this case, it's a regular pod, and we're going to kubectl exec into it since we can. And we can see there that we're using the service account that we just looked up. So when we apply this, a new pod will be created, and then we can kubexec into that, and we'll be able to find the token, which is a web identity token from AWS, and this will be, we will be able to assume that super powerful role just from using this token in an AWS STS assume role with web identity command. So I exported the token to make the command a bit cleaner, and then we're running this command. And now when I do AWS STS get identity caller, we will see, oh, I need to export the actual tokens first. So let me fast forward a little bit. Okay, and now STS get caller identity, and as we can see, we are now the AWS admin equivalent role. Again, the mitigations for this are the same as before. Use Argo CD projects. You can also use Crossplane compositions. Those compositions are sort of like templates of things that you want your developers to be able to create, and then you can use Argo projects or RBAC in Kubernetes to delete all the other resources, to avoid other resources from being created. Also, when you're managing IAM permissions, you should be using permission boundaries. Yeah, overall, least privilege always. Conclusions, I don't have time to go over all of this, but essentially, CI/CD is very useful, but very dangerous, and therefore, we should be protecting them with all the mitigations that we talked about in the past. And that's pretty much it. Any questions?
Thank you very much, Ignacio. This is a great topic. Actually, I think this is something that is well, increasing the attention that it should be receiving from the cybersecurity community. It's great to have demos like this one, where you can see how you can just pivot through different platforms, compromising everything on the way. So it's great to have your talk here. I don't know if we have any questions in the room. You can ask in English or in Spanish. Just raise your hand if you have any. In the meantime, maybe I can ask you one question. Which is your favorite one you have discovered that you just say, like, I cannot believe it, I just started with this position and I arrived in this place?
I would say the Crossplane one, because in this scenario that I've showed, it was quite simple. But in the scenario that I actually exploited this, it was way more complex. It involved a complex multi-step chain of trying to pivot through different parts of the cluster in order to get enough permissions to read the token from that IAM role.
And any question in the room? Not yet. Not yet. Okay.
I don't know if it's because it's late in the afternoon, or I just melted many brains with Kubernetes.
So let me ask you one question. So when I learned about Kubernetes, I found it to be kind of terribly vulnerable, no? Because there are a lot of different permissions that are going to ask you to just create pod, steal service account tokens. There are a lot of ways to pivot and to compromise Kubernetes, I guess. Do you feel the same way? Do you know if there is any special way to make Kubernetes more secure?
So Kubernetes is incredibly good. Like, it allows you to do so many things. It's so flexible, and it basically can do anything. The thing is, because of that flexibility, it's really difficult to configure correctly. So teams are failing to configure it correctly. One thing that is kind of in the hotspot right now is admission controllers. Since pod security policies have been deprecated, now admission controllers are kind of something that everyone has. And those allow you to really determine what is possible to be created in your cluster and what not. And that's a great defense against most privilege escalations that don't involve like an attack to the kernel directly.
Yeah, a 0 day, something like
Yeah.
that. Okay, last chance to ask a question to Ignacio. Not really? Cool. Thank you very much, Ignacio. It was great.
Thanks for having me.